Good afternoon, ladies and gentlemen. My name is Guillermo Orts. I'm speaking from IBEC, the Institute for Bioengineering of Catalonia. It's my absolute pleasure to welcome you, all of you today, to the first activity of the 2021 BIST conference. As you know, this is the annual meeting of our community, collaborators and stakeholders. This year, the BIST conference from the Barcelona Institute of Science and Technology is focused on quantum technologies, one of the BIST research priorities. Today, we are here in this pre-event on a satellite session to discuss about an amazing, interesting topic, which is science communication and much more. More specifically, very well welcome to the satellite session about how to communicate complex scientific topics. So, in order to address this issue, we have today with us three fantastic panelists with different profiles, but something in common. They all try to bring some light into how to explain complex scientific issues. And before starting with the panelists, I would like to bring you a quote, maybe bringing some inspiration to start the session. I can safely say, nobody understands quantum mechanics. These are not my words, but from Richard Feynman, physicist, awarded with the Nobel Prize in 1965 for this work on quantum electrodynamics. You would say, okay, that was very long time ago. Of course, everyone can understand quantum mechanics. But what if I tell you, only 2 years ago, in the New York Times, Sean Carroll from the California Institute of Technology was saying some words in the same direction as Richard Feynman many years ago. He stated, even physicists do not understand quantum mechanics. So, ladies and gentlemen, we are in 2021, and we have still many open questions. Is this true? Is this not? What about other complex topics? Can people really do not understand quantum mechanics? In order to bring some light to these questions, we have here three fantastic speakers, experts specifically into communicating complex scientific topics. So before starting with the first panelist, please let me explain the agenda of the session today. We will have three speakers, everyone presenting their experience on this topic, on this amazing topic. 15 minutes for the first one, 15 minutes for the second one, and 15 minutes for the third one. What about the questions? This is a very important part of the session today. All the questions will come or will be answered or try to be answered at the end of the session. So please, during the talks, you can send us your comments, questions, everything you want to send us. And at the end of the contribution from the speakers, we will discuss all together about your questions. So, without dilation, I would like to start introducing the first speaker. It's my absolute pleasure to present here today José Ignacio Latorre. José Ignacio Latorre is a quantum physicist, as Richard Feynman, but moreover, he's the director of the Center for Quantum Technologies in Singapore and chief researcher of the Quantum Research Center and Technology and Innovation in Abu. He got his PhD in elementary particle physics and has worked extensively in quantum field theory, particle quantum information, artificial intelligence, so many amazing complex topics. Moreover, his outreach activities include writing of 3 popular books and the production of 2 documentaries. José Ignacio Latorre was also the scientific advisors of Quàntica exhibition.
Hello? I lost your... I think I didn't get... There is some problem, Guillermo?
We can hear you, José Ignacio.
Okay,
I think
okay.
everything is fine now.
Okay, you got frozen, so that's it. Yeah. Okay, thanks a lot, Guillermo, for the introduction. And let me, in these few minutes, try to bring some ideas that we may use to discuss later. The very first idea I wanted to bring forward is why many scientists are a little bit away from outreach. At least, during my life, I've seen many people not participating in outreach programs. This is changing, may I say. There is a dramatic change in recent times. But just to bring some of these ideas forward, I think that many researchers have this idea that the information, scientific information in media is often wrong. It is unfaithful. It is biased. Science is often presented in a negative way. It's a dystopia in general, what you see. And often it's fake. If you go in social networks, the amount of fake science you get is very impressive. So for many of my colleagues, and for myself, I accept that, it's easier to remain silent and not to participate in the outreach effort. Let me be a little bit more precise. Why is it better to remain silent? Well, many scientists do not like to be used. They don't want to be manipulated in any way or another. I myself, I must say that I remember one particular article that the title that was chosen by the journalist was completely off, was an absolute misrepresentation of what I had said. Next day, without any complaint from my side, I received a note from this journalist apologizing for what he said, for the title he had used. But my feeling was that I was used. Then, come on, we fear our peers. Okay, we are never good enough. We never say the things in a right way. So we are in fear of our colleagues. Many times we think we are boring. That, come on, we don't have a particular gift to talk to a general audience. We were chosen, we were filtered in our careers because we do decent science, but that doesn't mean that we are an entertainment for many people. Actually, we don't even know how to convey a message. And often we simply find, we interact with journalists that may not be nice to us. They are urging us. They complain that we are not doing the right thing, that we are not using the right spirit. So after a while, you say, well, come on, let me alone. And nowadays, we fear backslash. There are too many haters around. And that, again, I think everybody has the same experience. It's simply amazing that in the most positive spirit, you give a talk or an interview, when you see the reaction, there is a minimum percentage always of people that really hate you. So why should you go there? So this is in particular relevant on the TV. Let me say in advance that TV for me used to be much more important than it is now for outreach. at some point, people were watching TV. Now, this is not so. People really watch offline contents. But let me stick on TV. Okay, so why there is so little production, scientific production? Let me make it clear. We live surrounded by lasers, by smartphones, by computers, by GPS. Our life is full into technology, yet the amount of information we get about this technology is really negligible. So, well, the first thing is that TV is a difficult subject. This is commonly agreed by any TV, the middle and high managers of TVs. It's a difficult subject. How do you handle it? They are not trained for that. Then many of the scientists do not understand, do not follow the communication standards. So it's very difficult to make a program with scientists. The topics may be even extremely abstract. Try to say something about deep mathematics. What can you really say? The production is expensive because often you have to produce it very well. It's not an easy production. Think again of biology or wildlife. If you have to go to the Antarctica to film, it's very expensive. And then there is some amount of science. So why don't you buy it and you screen it, and that's it. So you cover, your grids with the minimum amount which is acceptable, and that's it. And even if there is a production of for TV, an audiovisual production for science, it is not screened. And again, in general, the management of TVs consider science only suited for attentive audiences, so those that really pay attention for more than 20 minutes. The scenes of a sitcom are below 5 seconds each scene, the change of the camera. So 20 minutes is too much already. And TV is about your feelings, your guts, not your brains. I remember a guy who was trying to make a program about how the heart works, and he was telling me that the excellent beginning was taking images of one of these accidents that some soccer players have in the field, and they eventually, some of them have died, and following how it is treated. They want to bring the guts, not the brains. Then it's not profitable. How much they pay is very little for a screening. And there are channels, very few. In North America, you have more, but there are channels. So why don't you subscribe to that channel? So whoever is interested in science has a small niche where he can really go ahead. And one of final sentence, TV is not a public service, okay, for many of these people. Now, all these things I'm saying may seem a little bit peculiar to you, but actually I'm bringing them because we conducted a research with Maria Teresa Soto Sanfiel and myself. And it was about uncovering the attitudes towards science, scientific contents, and scientists of mass media communication professionals. So we interview an amazing number of these professionals, and we ask the questions that you have been seen in these screens. So the answers that you are seeing here are the results of this experiment or of this research. As a matter of fact, there is no more science on the general TVs because the people that take the decisions of what is to be screened have a negative bias against science. So it's a fact. It's not. It's statistically obvious. So this was my first comment I wanted to bring to you. My second set of obvious comment is that instead of what's going on, there is a need, an absolute need for outreach. Science is culture. It's the engine of economy. A society who is illiterate in science is a weak society, in particular in the 21st century. Our economy is based on knowledge and needs good outreach. We need scientific role models for the younger generations to join science. We need well-informed business people to make decisions. And definitely, there is a tremendous danger around fake news. And I think that the case of the virus, of the COVID, is an amazing example of the dangers of having fake news. Well, again, let me bring ideas for the discussion later. Why don't we think a little bit in a different way? Why don't we put everybody on the same bag and we try to understand the audiences? So why don't we start to dissect? And by far, this is not the dissection of the audiences. This is just to show that you can think that you are, popularizing science with targets. So maybe you're talking to decision makers. You're in a talk to decision maker. Maybe you are just talking about what is the business around science, or you talk to the elder audiences, or to night hawks, or you have very attentive audiences that want to listen about science. You have youngsters who are trying to decide what is their future, or you have parents that want to bring the best education to their kids, or you have science lovers, and many, many other categories you may invent. Of course, you have to use different ways of communicating science and different science to be communicated to depending on the audience. So this is an idea that when we talk about communication, we should ask the standard questions: who, what, how. I think it's the most important is who, then what and how. And there you may have combinations. So for instance, think of parents that want to educate their kids. So they want to bring education in science. And what they do is they visit the Science Museum, which is particularly good for that. Or you have a science communication expert, and he has a particular contribution in a journal or a blog or social media, which is focused on entertainment. So he will look for the news that might be more enticing and will write them in a particular way. And he will use a language and a schema. So typically a format which is adapted to the who and to the what. So the comment is that what I think is necessary is for us researchers. Now I'm focusing on and all the set of people that can do outreach. I'm putting myself in my skin. I don't know about. My colleagues will talk about other points of view. So, but for me, what is it? What can we do, the researchers? Well, definitely we should be in charge of communicating advanced science. What is going on in the labs, it's us who know. So if we really have a new particle, okay, or a deviation of a standard model at CERN, it's us who should tell that. If we are finding a quantum computer, it's which is particularly better platform than any other, it's us who should say that, because we understand in detail the physics. We should also bring a faithful vision of science for politicians. I think a big mistake around the planet is the absence of communication of what is science and what is the good science to politicians. Then for the general public, I think we should bring basic, clear, faithful concepts. We should be a trustable source, okay, trustworthy source of ideas. And definitely we should do a lot to show how we make science, the making of science itself. It's the best weapon we have to entice the enthusiasm of youngsters. And then finally, let me just bring a little bit of my own experience. So I've been devoting a lot of effort to communicating science. I've tried many ways. I made here a few of the, some of the things I've been doing. So I've been writing books. They are in Spanish. I wrote about the nothingness, about quantum, about ethics for machines, for artificial intelligence, and now I'm finishing a new book on the atomic bomb. I've been participating in exhibitions, and the big one was together with Mónica Bello, who is today with us, and I hope she will tell you about that. It's an exhibition that went for 6 months at the Center for Contemporary Culture in Barcelona. Now I'm trying to make another big one. It's fake in Singapore, and others. I did one in the year 2005 about aesthetics and physics. It was very nice. It's circulated in many places, and it involved people that were not scientists. I also did 2 documentaries, one in Spanish, one in English, and the second one has been screened in many countries. It's about the atomic bomb, and including Japan, South America, all of Europe, Asia, plenty of places. And I've learned a lot by being in the screening of a documentary. The reaction of the people is really amazing. And then talks, not to be underestimated, giving talks of science in schools. Later I've been approached by people saying, "Yeah, you came to my school, gave a talk, and I changed my direction in life. I decided to go for physics." Or to business, or to politicians. That's relevant. I think a lot can be done. Or to large audiences, very large audiences. I remember one talk to thousands of people that were very religious. It was about a non-trivial subject. To the elder. So I think that this is a fundamental fact. People like to talk to a scientist. They rarely do that. It's very seldom that people have the opportunity to talk to somebody who has been doing a lot of research. And I think this is the end. This is my final transparency. Well, my second to last, let me say that I try to be always straight, fair, and faithful in my presentations. I do not use too many analogies. I think that often they bring the wrong message. Let me say, Schrödinger cat is not life and death at the same time. It's wrong. I do not accommodate to standards for simplifications in general. I take care. I try to take care of the speed of the wording, of the delivery. I try to engage with the audience, typically walk in the audience myself, and I try to show my love for science. And just to justify my last comment, let me finish with a quote by the Count of Balfour, Arthur Balfour, in his book Decadence, 1908. So this is more than 100 years old. And he says, "But science is the great instrument of social change, all the greater because its object is not change, but knowledge. And its silent appropriation of this dominant function amid the din of political and religious strife is the most vital of all the revolutions which have marked the development of modern civilization." So that's it. Thank you for your patience.
Excellent, José Ignacio. Thank you very much. I think that was a perfect start of our session, because we have started with Richard Feynman telling us nobody understands quantum mechanics, and from one physicist to the next one, which is you have pointed out some of the challenges of doing good science communication. You say science is a difficult subject, and that's true. And there is a very crucial need of outreach and to do it in a proper way. And science is part of the culture. And many other things, the crucial questions, who, what, and how. And also, you pointed out the need for scientists, for researchers to understand their audiences. And so starting from the challenges, you also have sent to us some tips, some things you try to do in your science communication. And I think this is a very good starting point to have some light in this very difficult question, how to communicate complex scientific issues. Thank you very much, José Ignacio.
Thank you.
And looking forward to hear your comments during the questions part of this session. And so if you allow me, I would like to go to the next speaker, because we have here today, as I told you, 3 very different profiles, coming from a physicist to another one, and now we are coming to the second speaker, because as José Ignacio also pointed out, there are many ways to communicate science, and I think Mónica Bello is one of the person who can tell us which other ways we have to communicate science and how to do it in a deep way. So if you allow me, Mónica, I'm gonna introduce you. It's all my pleasure to say a few words about you. Mónica is an art historian, Mónica Bello, and has been curator and head of arts at CERN since 2015. For those of you who don't know this program, Arts at CERN fosters dialogue between artists and scientists. We're at one of the world's leading laboratories. So Mónica Bello co-curated the exhibition Quantum Broken Symmetries that comprises 10 artworks from art at CERN. This exhibition toured internationally for 2 years, not for 2 weeks, for 2 years, including the CCCB here in Barcelona. And he has contributed to great, very interesting projects at this interface between science and arts. And of course, he has been also the co-curator of Quàntica, this great exhibition we had the privilege to enjoy here in Barcelona. Moreover, only two more words about Mónica. She has been the formerly artistic director of BIDA in Telefónica Foundation and head of education at Laboral Centro de Arte Gijón. So, Mónica, the stage is yours. Thank you for being here.
Thank you very much. Thank you first of all, for inviting me to this the annual conference. And I'm going to start my slideshow where I see the whole title of this panel. So this panel, how to communicate complex scientific topics. I really enjoy, José Ignacio, how you answer this question directly. I'm going to do it indirectly by describing how we do it and how we make tests and trials to conclude in many different programs that engage not only the audience, but also the scientists at the lab and the artists. And our goal is really society, how art and science are part of culture. We like to say that it's creativity across cultures, and creativity is a pillar of our society, or it should be. We claim that it is. So how we deal with that between art and science. So the place where I work is a picture here by the artist Thomas Struth. This is only one of the machines in the Large Hadron Collider. CERN is the European Laboratory for Particle Physics. The main purpose of anyone working here, including me, is to understand that and to convey what we know about the universe. In this case, these machines, these large experiments, the largest experiments on Earth, are looking into the subatomic matter, and they are the Large Hadron Collider is well known by for the fact that it's colliding protons, and with these collisions, new events, new phenomena happen. And the scientists here are capable and able and happy to say the things they know about these collisions, how this helps them to map the subatomic and the micro world, which is everything around us, inside us, from the beginning of the universe to the end. So this is the place where I work. And since my arrival in 2015, I've been expanding and developing programs to foster the dialogue between art and physics at the lab based on CERN's cultural policy. The arts program was created to foster this dialogue because we believed that this dialogue was productive, encouraging another way, a different way, and a very diverse and heterogeneous way to talk about science, bringing highly professional creators into the lab to ask difficult or very simple questions. This is something we do by inviting them to experience the way the big questions in science and fundamental research are pursued at the lab. And we do it as well because our goal, one of them, is to inspire significant exchanges between art and physics and to participate in an international community, which I know and we know is eager to connect with CERN. So I'm going to describe what we do by telling you the things that we have been doing. But before that, I think it's very important, and you will guess this through my presentation, there are some ingredients that are essential for us. And one of them is collaboration. So science, before I arrived to CERN, I had this perception that science is something loners do, and it's a very individual activity, and anyone can do science at home, or things or preconceptions that we often believe or guess from media messages and from scientists, but not. At CERN, there is 15,000 people collaborating, and this single experiment, the one you are seeing on the screen, the Atlas experiment, is only one in the Large Hadron Collider circuit, but there are 5,000 people working on it. So this machine, which is the largest machine on Earth, is as big as the Cathedral of Notre Dame with the cavern and everything. We use often this analogy. I think it's even true. This has been built by thousands of people, bringing parts and bringing knowledge and coming to CERN to make it happen. And this machine is so complex that the calibration and the synchronicity that they need to achieve on the process is enormous. Is something that I often think is beyond human. But no, these visionaries, these experimenters, they manage to make this machine happening. So collaboration is very important. And collaboration through residencies, being part of a community that is asking questions at the lab. So the artists come and join a community based on collaboration and based on being together. We do this and we take this idea by, in the collaborations we organize with international institutions and of different nature. And a clear example is the Collide program, which is flagship residency, and is now being organized in collaboration with the Barcelona City Council in connection with their Plan de Ciencia, the scientific planning. So partnerships, collaborations. We do that, different kind of collaborations and partnerships. And another example was the Quàntica exhibition, the exhibition that was organized by a consortium of cultural institutions in Europe. These institutions were interested in opening the scope of their activities to art and science in connection with everything we were doing at CERN. There is only a few places in the world where you can bring people to do a residency, artists to do a residency in such a large laboratory and large community. And these institutions believed that they could join us in creating exhibitions and artworks. The result of it was the Quàntica exhibition that many of you have saw in Barcelona, or some of you might have visited in Liverpool. Lelia Yannick was involved in IMAL in Brussels, and we brought 10 artworks from our programs. Partnerships that happen as well with education and outreach. It's clear to me that the interest of science is genuine right now. All the museums and institutions that want to experiment with new practices, as well as the artists, are bringing art and science into their programs. And this is a very rewarding example that we had last summer during the pandemic. Was a collaboration with the Victoria and Albert Museum as part of their Alice exhibition, and was joined by more than 5,000 students and teachers from many different schools all around the world. How we do this? The core of our program is artistic residencies, because we really believe and we are focused on the artist. The artist and the scientist working together, those things that keep us inspired and surprise us as well. Because by bringing very curious people together, you create collisions in between them, and many ideas that you would not expect come together. Also, and I always like to say this, we are in a moment in our society where disciplines try to tend to look at themselves, and by listening to the artists and the scientists, I think something they are looking for in these exchanges, in these dialogues, is to see their disciplines with the eyes of others. And this is very important. We cannot underestimate the need we have to share, to express what we do, and to think that it's relevant for someone. And I have a confirmation every day. And these exchanges are not product or delivery oriented. They are processes. Sometimes these processes fail, sometimes they are more successful, but they are conversations where people try to understand each other. And this is very important in our society today. Exhibitions, as I said before, I won't go into the detail in the Quàntica exhibition, but as José Ignacio said, this was a teamwork of 2 curators and a scientific advisor, as well as the amazing team of the CCCB. But what we did really well was to connect with the science in the city. Many scientific groups and scientists, individual scientists, as well as people interested in science from different angles, came to be together in this exhibition. So we brought different voices, different questions, many topics that were very complex to convey and to express, and many different moments in science in the last 67 years, which is more or less what CERN is, CERN's age. So we were very surprised by the amount of visitors, and this is something very important to remark, because when we were organizing a project on Quàntica and physics, we thought, okay, let's be realistic about this. It's going to be an okay number of visitors, but we were the third exhibition most visited in the history of CCCB at that time, which was, wow, impressive. So later the exhibition went to museums, traditional museums like the National Taiwan Museum of Fine Arts, or it went to Tallinn as well, to the Kumu Museum, which is equivalent to Macula in Barcelona. So it traveled a lot. We had more examples of art commissions, not exhibitions. This huge curatorial project of 2 years became less demanding with art commissions, which is something we are focusing on right now. We want to not tell about the science, but support artists and scientists working together to tell us about their ideas of science in many different directions. Diversity is very important for us. So a very well received artwork was Halo. It was in Art Basel for the first time. It was on Other Big Art Commission, supported by the watchmakers, curated by me as guest curator. And in this project, the artists who spent several months with us, they try to depict the Atlas experiment, which is one of the experiments at the Large Hadron Collider. And they try to bring the moment, the phenomena of the events, of the collisions into the gallery, which I think they did very well, and is a very compelling way to connect with collisions in different time and scales, of course, because Halo introduces us and invite us to be part of these collision events that happen at another a very different range of temporal range and space range that we cannot even imagine. But they did it very well, and now Halo is touring in UK. It's still, touring is a very complex installation, but I hope to see it in other spaces. So Financial Times and many other newspapers and art media feature exhibitions like Halo, Quàntica. We are also in Nature, New Scientist, and there are many papers about what we do and what the artists do. So what about the CERN community, which is one of our targets? They are our target audience, but also we cannot do anything without them. So I just compiled 3 quotes in which you see what some of our colleague scientists are looking for, or their impressions of working with artists. In the case of Chiara Mariotti from the CMS experiment, she says that working with artists reminds you on the purpose of what you do and reinvigorates your determination towards fundamental research. I think it's a beautiful quote of Chiara. Alessandra Necchi worked with several artists. She's a theoretical physicist, and she says that an artist can shock us with perspectives that challenge our logical views, but they offer our mind a chance to escape from the rules of physics and find creative ways to approach our research. And Regis Alemani, experimental physicist at CERN, working until recently in the Large Hadron Collider, she says that working with artists allows me to convey my passion for science in the artistic realm. So the conclusions are that I'm convinced totally that art is a powerful tool for conveying the complex language of science to the general public. Since the inception of the program, we have developed to become a reference for the engagement between art and science, adding to CERN's reputation as a place of innovation. The program enables the laboratory to reach new audiences, new creative communities, and engage the public in supporting of science through creative media. We have, and this is very important, a cultural policy of the lab, in which is the foundation of Orts at CERN, and we try to renew it and adapt it to the new times. After 10 years of funding the program. And then these 10 years gave us the experience that there is a significant interest in the arts programs at the laboratory, in our laboratory, but also in other laboratories in the world, because science is a foundation for society, and is giving us the image, the mental image we have about nature. This is what science is giving us. So there is a great degree of responsibility of what we need, what we are doing in the world and in our society today. So I'm going to leave it here. Thank you very much. And I'm looking forward to the discussion later.
Fantastic. Thank you very much, Mónica. I have to confess, I'm very impressed. And I was just writing some few words about what you said. And I think you introduced very, very interesting concepts like creativity, partnership, collaboration, to mix different curiosities. But my favorite quote of you was to see the things with the eyes of the others. And I think I see here a common point between José Ignacio talk and your talk, but I would like to just to point out an excellent final remark about your presentation. And coming back to Richard Feynman, who was the figure at the beginning of this session telling us nobody can understand quantum mechanics. So in another occasion, he also said, I have a friend who is an artist. So Richard Feynman, the physicist, had a friend who was an artist, and they have a very interesting relationship. And I have to confess, hearing you, I think you brought this concept to another level. So these partnerships, these collaborations, these different points of view, curiosities to see the things with the eyes of the others. I think this is fantastic. Congratulations. And I'm also looking forward to the discussion. I'm sure there are very interesting questions. Thank you very much, Mónica. So we come to the third speaker. And this is, again, a different profile. And I think this is fantastic because this is exactly what we're looking for. Different point of view to address the same question. How to communicate complex scientific issues. So it's my absolute pleasure to introduce José Luis Crespo. Probably he's very well known for some of you. I think for many of you, because Crespo is the founder and director of Quantum Fracture. And not only this, José Luis is a physicist, founder and director of Quantum Fracture, which is an animated channel dedicated to showing how incredibly crazy and quantum the universe is. So the YouTube channel you're managing has nearly 2.5 million subscribers and more than 120 million views. So positioning you, your channel, your work, your project as one of the platforms, more important platforms for creators of popular science in the Spanish-speaking world. So I think it's clear you're a pioneer, exploring new media, new ways to explain science, and I'm really delighted you are here. Thank you very much, Crespo. The stage is yours. We cannot hear you.
It's amazing how working in an internet environment, you forget to press the right button. Sorry for that. And thank you again, Guillermo, for the presentation. And thank you very much to the organization for the invitation. It's a pleasure to be here. And I might say that all the key points are mostly done. So let me be a little bit more specific because we are in a conference about quantum technologies, and I like to speak more precisely about the outreach of quantum mechanics. So if later in the third part of the session you want to do more general questions, I will be glad to answer it. But yeah, so quantum fracture is our YouTube channel. We opened it 10 years ago, and yeah, it's been a short experience talking about science with the internet, but I think it's been a very interesting and a very thoughtful and a very profound way of understanding how to speak better with a general audience. And yeah, our channel is focused mainly on physics. We talk about physics. We talk about astrophysics, cosmology, which is the part of physics that I'm a little bit more specialized. We talk also about condensed matter physics, about materials, which is something that in outreach is a little bit forgotten, maybe. Sometimes black holes are sexier things that some materials, and we need to talk more about the great science that in material science it's been made. Also, we like to talk about social topics that are relevant, like climate change. We have talked. We are now in the creating a series about how the electrical system work. And yeah, we like to talk about abstract things, abstract topics that are complex or are complicated, and we try to make them easier to people to understand it, to not just having a good time with it, which I think outreach has to be also that. It has to be entertaining, but also to make good decisions. But yeah, quantum mechanics and speaking about quantum physics is something that we've done a lot, and we are we like to do it in a certain way. For example, this frame is one video that is called "The Atoms Are Not Like This." It's a video that we talk about orbitals. We talk about how atoms are really like, and we try to disentangle some of the misconceptions about how we picture atoms and so on, and we bring the quantum picture in a fun and pictorial way, as you see in this frame. So mainly what we try to do in quantum fracture, in every piece, in every video that we make, is that we try to innovate. We are people that we've been involved in the outreach world for many long time. For example, I started studying physics because I read a lot of books, I watched a lot of documentaries, and at some point you feel that everybody's telling you the same thing. At some point you get tired. At some point you see some conservadorism. At some point you see that everybody is using the same analogies, and they don't want to pass through some lines to put it in that way. So in quantum fracture we try to do the opposite. We try to explain things that nobody has explained, or maybe talk about details that people don't want to go into because they are very complicated and people are not going to understand it, and so on. So we try to do that innovation, and well, in quantum things, in quantum physics, we've done it a lot actually, and very proud. For example, this frame is one of a video that is called "The Quantum Mystery of Air." In this video, we explain that, and many of the researchers that are watching this will know that when we speak about quantum mechanics, most of the time we start talking with the black body radiation and the birth of the photon, for example, as the first experiment that brought up quantum mechanics, which is not true. The first one was the measurement of the heat capacity of demolecular gases, and we explain in this video that problem and how it relates with the quantization of energy. So as you see, we could talk about the black body radiation, but instead we did this video because we think it was clearer, and I think it was new. So we do this a lot. For example, another example is one of the videos. Well, not one of the videos. The most watched video of our channel, which the title is translated something like "This experiment will leave you crazy," which is a very clickbaity and very fakey title. But actually, this video is about the double slit experiment. And if you know what the double slit experiment is about, you know that this title is not misleading at all. It's completely precise. In this video, for example, instead of performing the double slit experiment with a double slit, which will be the most intuitive and the most traditional way of presenting. If I'm not wrong, this thought experiment is original of Richard Feynman, actually. Instead of that, we did it with two boxes. And splitting the slits in two boxes allows you to put more information and to be more precise in the quantum effects that are happening here. For example, I'm proud of this video, of this script, because something that lacks in the original explanation of the double slit experiment is that you don't explain very well why certain pattern that appears in the screen implies that something is going through two slits. Not really. And with this disposition of the experiment, it becomes very, very clear. So here, another innovation that we think that was made. Also, this video was accompanied with other one when after explaining what is the wave function, which is a very powerful concept in non-relativity quantum mechanics. We explained how the double slit experiment can be explained using that concept, and was a very, very popular video also. The video, actually, the double slit video has already nearly 10 million views, which is a crazy amount of views for a scientific video. So in this path, we've located some issues when people talk about quantum mechanics, and we try to fix these issues. The first one that I found is the old quantum mechanics. It's trying to impress people, or trying to explain quantum effects using all quantum mechanics concepts. For example, it's a wave-particle duality. Actually, this video that we made is called wave-particle duality is rubbish. Can be translated like that. And basically, we use the excuse of talking about what is a wave-particle duality, how this concept emerges, and explaining why it's not something relevant today, 100 years after the birth of quantum mechanics, and how we use something more powerful than the wave-particle duality, which is the concept of wave function. This video actually is a way to explain what is the wave function, and it's a way of resolving one of the misconceptions, that is that wave-particle duality is something fundamental, let's say. So yeah. So black body radiation problem is cool, as we said. Knowing the history of quantum mechanics is cool. I think knowledge without history, not knowing where the history of your of the things that you are studying are not really knowledge. You have to know the problems, and you have to know how the thing went. But I think that is not very pedagogical. is not the best way of teaching quantum mechanics. I believe general relativity, the way that the history of general relativity, how general relativity was cooked through the equivalence principle, was a very good way of introducing someone into what is general relativity. Quantum mechanics is not. The history of quantum mechanics is completely puzzling and random, and it's not the best way of introducing someone to it. So, what is this? What is the best way? What we found is that videos as this one, what a qubit can taught you about quantum physics. That is a video based on a very famous introductory paper. We found that was very, very good in introducing what the Bloch sphere was and all the quantum physics concept in the position that someone that watches it, we think that already has all the concepts to start studying more advanced topics on quantum information. That is something that is very demanded, quantum computers and so on, and many people that was interested in quantum information and most of them engineers related to computer science and so on, they really liked this type of videos. Another example, more in the entertaining way, because this video is more technical, because we are showing you most of the technical way that the way quantum mechanics work. But this one that is more in the entertaining focus is called "I Challenge a Grandmaster to Quantum Chess," and actually it's a video where we play quantum chess with someone that knows a lot of it, and I explain it to her concepts of quantum physics, and we found that in this video, with this type of configuration, the quantum chess, the idea of entanglement comes so easy. It's the best way that I found that you can understand what quantum entanglement is. It comes right away with this approach of teaching the rules of quantum physics. So another, and the last one, it was only two, and the last issue that I found is the inconsistency with interpretation. Quantum physics is a very powerful theory, but when we do outreach, we just don't talk. We don't talk in terms of this is a theory, this is a model. We don't talk about Ketz and Brass and operators and Hilbert spaces. But we bring those things to the ground, and when we do that, we have accepted one of the interpretations of quantum mechanics, and that brings some issues when you are not aware that you are doing stuff like that. For example, this is another video. The translation will be something like the uncertainty principle has a rubbish name. And this video is about explaining what the uncertainty principle is and making this point that many people in outreach, when they try to explain what the uncertainty principle is, they use a lot of analogies and thought experiments that makes you think. And the name of the principle is not helpful at all. You think that the problem is that we have a problem. We as humans, as physicists, as scientists that want to measure the universe, you have a problem knowing what the velocity and the position of the particles are. Like we have a problem. We have a problem knowing those values. Like we have a lack of certainty. No, that is the name that is implied in the name. Where I think that most physicists, if you ask them these questions, they will tell you that is not that way. That the problem, that the quantum, the real quantum effect is that particles has no in certain conditions, some of the properties are not defined. So it's not our problem. It's not. We don't have any problem knowing those quantities. The problem is that are not defined in the first instance. So we try to make a point that a better name of the uncertainty principle might be the indeterminacy principle or something like that. So someone could say to me, well, that's true if you follow a certain interpretation of quantum mechanics, because I don't believe, or I don't think that the properties of an object are not defined, because I follow some interpretations of quantum mechanics, a Bohmian mechanics interpretation. I follow hidden variable interpretation, and that's it. That's a fair point, actually, but you have to be very specific with that. And this is one of the keys that I found, that talking about quantum mechanics is filtering through an interpretation. So you have to be you have to be very you have to be careful with that. And if you are not going to follow one of these alternative interpretations, most of us, that our interpretation are slightly aligned with the Copenhagen interpretation, well, you have to you should do outreach in the line that most physicists are. But that's and I will be finished with this, and I will finish with this. Interpretations are also a very nice topics to talk about, and actually we are now in the channel talking about them, talking about the different interpretations of quantum mechanics. That is something that is stuff that is not no, there are not many outreach about it. This video, the day that Einstein almost kills quantum mechanics, is about the EPR paradox and what entanglement is. A video follow it that is called The Experiment, that show the crazy stuff of quantum mechanics. It's a video about Bell's inequalities. We are very proud of this video because we managed to make the Bell inequality completely conceptually understandable, let's say, with a thought experiment. And finally, we've started talking about these alternative interpretations of quantum mechanics. For example, this one called The Deniers of Quantum Mechanics, that is about hidden variable interpretations. And we will follow with these lines, because we want to innovate, and we want to talk about quantum physics in new ways that many people, with some fear of not being well understood and so on, maybe don't jump into it, but we'll do. So thank you very much.
Thank you very much, José Luis Crespo, founder and director of Quantum Fracture. So I also took some notes from your presentation, and obviously, as I said, you are a pioneer. If you think of people talking about topics on digital platforms, you probably will not imagine that the kind of things you are telling people and how successful you can be doing this. So I know the word innovation. So you try to innovate, to break down conservadorism. This is very nice. I think this concept to break down conservadorism in quantum mechanics, it's new to me, but I think it's really, really deep and interesting. And I also know the third concept, which is to bring things to the ground, okay, and to break conceptions. So obviously you brought here some more ingredients, which, in addition to all the presentation from José Luis and Mónica, I think we have a lot of ingredients which can lead to the discussion, if you like, now. So if you join me now on the stage, please. Thank you very much. Before coming to the first question by the audience, I would like to make in 30 seconds a summary of some of the things you brought here, okay, for the discussion. Things I didn't comment before, and maybe you will help for the first question, I hope. So, José Luis, you spoke about many interesting things, but you also mentioned because we love science, José Ignacio Latorre, and I think this is important. And you, Mónica, spoke a lot about curiosity and to see the things with the eyes of others. And you, Quantum Fracture, spoke about to break conceptions. So maybe these are not the words you expect when experts are coming to the stage and speaking about science communication, but maybe they are crucial. I don't know. I'm not an expert as you. So that was my summary. And if you like, we come to the questions. So, and our colleagues from the BIST were asking us something that you mentioned at the beginning, José Ignacio, was how can we change the negative bias towards science and mass media and decision makers? It's a matter of education. What do you think? What's the relation between communicating complex scientific issues and education?
Yeah, I think it's a very difficult issue. In a way, what is at stake is the fear to the unknown. Okay, we feel uncomfortable when we are confronted with something we don't understand, and our reaction is of fear. So, because we don't know what will be the future use of technology, well, every movie is a disaster. There is no movies about that will live happy in the future. It's everything about the bad use of whatever we are doing. So the negative bias, I don't think it's only about science. I think it's more generic. There is a study about the use of positive and negative words in the New York Times. And in the first half of the 20th century, it was more positive than negative. And around in the McCarthy era, it turned into negative and never came back to positive. So the average words that you read are negative. So I think it's just a fact that we prefer to read negative things and watch assassination movies and things like that. But if there is any way to balance this bias, is education. There is nothing else. Education is the only instrument we have to confront, the unknown and the difficult, possible difficult times. I insist that and I think the virus is an example. The most difficult thing is to confront a problem of this magnitude with a lack of education in the average citizen. This is extremely complicated. So I think that the negative bias, that I don't think it will go, will stay. I think the only thing we can do is educate better. Nothing but that.
Okay, José Ignacio, thank you very much. If I may add something to the question, could be maybe Mónica, that education is crucial, but that maybe education goes beyond the curricular education we thought in the past. And that's why sometimes we fall in this so-called literacy paradox, no? That you explain science to children in schools a lot, and they have the concepts, but they still sometimes don't like science. I don't know. It's just what do you think, Mónica, about this question?
It's a question that makes me react with some skepticism because I run an education department in a museum that was a leader at the time in art, science, and technology. So I thought a lot about this. So my first question to all of us is, when education happens? So when? Are we talking about educating kids? Are we talking about creating tools and experiences that allowed anyone in any age, in any circumstance to have the possibility to engage with topics that are still complex? So we could keep going on that direction. And where? So the when and where is in which part of our life, and in which context? There are many questions. It's a very complex question, I think. It's not as simple as let's educate and make better citizens. I think we need to find and invent and keep inventing new ways to engage with complex issues without just borrowing some metaphors, analogies, and try to make people react to it. I think our job is just that, through the arts, from science, from cultural studies. That's the key question.
So,
may I add, Mónica, you know that there are studies about why many women decide not to go into science, and massively is at the age of around 11. So it's between 10 and 13 that typically people, in particular women, decide this is not for me. For whatever reason, I'm not saying that whether it's a teacher, whether they were not exposed to role models, that I'm not entering. But typically the decision is at that stage. Whereas many people have been trying to do actions at the later stages, but then it's too late in general.
So thank you very much, both of you. And obviously you achieved to break down these borders of formal education with your exhibition at CCCB. But I also would like to translate this question, to address this question to quantum fracture, because obviously you have something to add here in terms of, I got from your talk, you try sometimes to promote. Is promotion some kind of way to engage, as Mónica said, and to educate somehow? No, I don't know.
Yeah, sure. I think that outreach is certainly a mixture of two things. It's a mixture of education. You have to explain things. You have to tell stuff, and you have to be rigorous, and you have to be respectful of the scientific material. But also, it's entertainment. You have to entertain. You have to do something that is an experience for the one that is watching it. And in my media, that is YouTube, which is a jungle where you open YouTube, all the videos appear, and you are basically competing with tens of people that are trying to catch the attention of the one who is in the front page. You have to fight there, and the way that we fight when we would talk about science is actually using the same tools. I think that when you talk about science, you are already giving titles and thumbnails, and you have something that is very powerful, very interesting, and that catches the natural curiosity of people. And I think that many of us that are working on YouTube and making this type of videos, we are kind of demonstrating that you can have a really good YouTube channel, and the material just shines for itself because it's interesting, because people wants to know, because people are, if you put it just in front of them, a video that is called "Atoms Are Not Like This," and the thumbnail is the classical way that we picture an atom, for example, people are going to click. People want to know, and people are going to learn a little bit of quantum mechanics. So I think new media and the new ways of making science communications are changing some stuff a little bit.
Okay. Thank you very much, Crespo. We have 10 minutes more, and I would like to address first, if you allow me, a question to Mónica, and then a question to all of you, all three. Okay, but this question, I think it's also interesting, and maybe it's good after the education question you answer now. And the question is from Federico Dattila, and asking Mónica. Thank you, Mónica. Impressive work. Congratulations. Any analogous examples of art-science interaction in other fields of science, for instance, chemistry, biology, etc.?
Yes, definitely. There are many. There are many artists engaging in the most experimental way in other fields. Life sciences is a good example. Life sciences also allows you to have a hands-on experience, which is something that particle physics does not. So it's you can look the experiment, you can engage in other ways, but you cannot go to a lab and just work with, I don't know, semiconductors and stuff, or build an accelerator. But life sciences is bringing many artists into labs to have to get expertise and to bring difficult questions, critical questions about life, and then computing as well. Engineering is a huge area, and the scope is endless for artists. So there are many people doing hardware, software at many levels in the different fields. I think lately I've seen people dealing with quantum physics, quantum technology, and proposing the potentials as well as a critical thinking around it. So I think science is very important in our society and is dealing with our own identity as society. So I think artists go always there. Artists are really reaching the edges, the most marginal spaces in our society to understand what we are doing. And this is why it's so important to make these processes easier, because they are the philosophers.
Thank you very much, Mónica. So actually we have two more questions for all of you. Let's see if we have time for both questions, but I would like to start with the following question, and maybe now more address to José Ignacio and quantum fracture. So, because Mónica, obviously you are in such a creative environment, and with your expertise, maybe for you it's very, very obvious. But for José Ignacio and quantum fracture, coming from physics, and the question is, how do you find these innovative ways to try to communicate science? For instance, for José Ignacio with your books, or the exhibition together with Mónica, or for quantum fracture, maybe how did you came to the idea to open your channel? Maybe do you want to start, José Ignacio, and then we go to quantum fracture?
So the question is, what is our experience, my experience?
No, how did you come to the point that you decide to explain science in a different way?
Well, typically I'm somebody, gets me there. No, I typically. But let me say that it's very fruitful and extremely, it completes our life. May I say, as a scientist, I need to have an act of beauty per day myself. Otherwise, it doesn't make sense. So let me tell you what the latest thing I'm doing in the center I'm directing in Singapore. We have opened a position for a resident artist with us, but the project is that he should make our life more beautiful. He's free. He can do anything. He can invent. He can change our landscape. He can introduce ways of thinking. But let's have a better life together. That's a purpose, nothing more. Okay? So it's coexisting, collaborating, co-discovering, co-exploring with them. And that's our purpose.
Excellent. Thank you very much, José Ignacio. So, Crespo.
Collaborating is one of the main ways that you find new ways to do stuff. For example, with friends or with my team, or you are explaining something to someone, testing some idea, and you find analogies, you find excuses to explain all that stuff. But also, I think that, and this happens a lot actually. But the great physicists, the great scientists, have already told the ways of getting through a certain all the ways of explaining a certain concept. Reading and reading physics is sometimes, and knowing more and more physics, and knowing the same, and trying to read the same concept or the same topic from different authors gives you really deep ways of approaching things, I think.
All right. Thank you very much. So we have more questions, but unfortunately only time for our very last one. Well, we have a question which is, who should explain science? And I think from your talks, if you allow me, I would also like to make a contribution here. I think the words collaboration, partnerships, co-creation, you say so many times, we should not exclude science communication only as a task, as a duty for researchers. Maybe the opposite. We should work together, we should help each other, and we should see with the eyes of the others, as Mónica said. But if you allow me, the last question could be for you, which recommendation would you give to someone starting in science communication? If it's an artist or if it's a researcher, a scientist. So would you have an advice, some tip, something can be a good advice to start to get in science communication?
I might say that the best tip that you can is learn about science. I think it's very difficult, the translation, getting in the middle point where you can communicate science properly in a rigorous way and in an innovative way. It comes, I feel, with the price of knowing very well or very, very well advised. And I think knowing more about science, even when you are a scientist, or even if you are an artist, trying to make through or go through the technical things, it gives you true insights to explain it better.
Thank you very much. What do you think?
Yeah, let me agree completely with José Luis. Often when you try to do something new, there is this technique that first you brainstorm, you expand, and then you concentrate, and then you get something new. I think in science it's the other way around. You should first go deep, understand it really well, really, really well, and then explode, find ways, because you have the knowledge and you want to implement it, you have to transmit it. This idea of going right away to the transmission of knowledge which is not sufficiently deep ends up in failure, in my opinion. Okay, so this is the fundamental thing about science, that there is a underlying basic law which is independent of humans, independent of race, independent of culture, independent of language. We use the very same notation for science all over the planet. We don't agree on the languages we speak, but we agree on the notation, on the mathematics. We agree on the laws. So it's amazing. It's obviously something that transcends the individual local cultures. So it is fundamental for me to understand it, for them to use any other mechanism. You can use the art, you can use literature, you can use, a very standard blackboard to explain these things. But otherwise, it's a mess, I think. So many things are wrong when you go around in, by definition, quantum is the word that everybody takes, no, for quantum sanation, quantum whatever. So by definition, that's a recommendation. Anything you read except for the quantum fracture, the rest is wrong. So try to. It's very difficult because many people want to jump ahead, definitely, and this is not what you should be doing.
Thank you very much. So, Mónica, if you want to have the very last word, because you come from the other side, if you like. Also, you are some kind of scientist too, no? Historian of arts. This is you are somehow also.
Yeah, but I've worked all my life with scientists and artists. So I think if I think I have a career of 18 years now, or maybe 20, depending on how young or old I want to be. but I think science is the correct term to say. A long distance running is something that you cannot take. A couple of speed courses and think that you know about it. So this is clear to me, and I have to agree with José Ignacio. It's not a provocation. It's just that we need to be very humble. It's a difficult subject. If you go to a kid of starting the secondary school and he goes like, "Hey, I love physics," and then they start physics and they think it's horrible, most of them. But the start is the difficult one. So when they get into the quantum, they start to get excited, black holes, stuff like that. Wow, all of this is amazing, but they need to wait and to have many layers of science, because this is how a language becomes a language. And this is clear to me with another way to deal with science, which is as my personal experience. I'm an art historian. I've been working almost 7 years in the laboratory, and now I can talk like a particle physicist. I have the jargon. I go to a detector and I know the parts. I go to a neutrino detector, which is the most beautiful machine. I know how this works, but it took me years of experience listening. It's like cooking. You look at your mom cooking, and one day you do the lentils exactly as she was doing it, and you don't know why. I think is that the experience of science is very important. This is why I think laboratories have to open their doors to provide this experience. It's not about this super nice, like headline. It's about experience and access. Giving access to that.
Great. So thank you very much to all of you. It was a very, very interesting session. I have to say, I'm convinced we address crucial points on how to communicate complex scientific issues. A lot of ingredients you mentioned, a lot of experience you brought to us on the stage, inspiring projects. And I think we will go home with a lot of things to think about: collaboration, partnership, creativity, engagement, science, and arts. Thank you very much, Mónica. Thank you very much, José Ignacio. Thank you very much, José Luis, for bringing us the science and arts of science communication. Thank you very much. And thank you very much also to all the audience for the questions, for your time, and for your interest. Just final words, I would like to remind you that that was the first event of the BIST conference, or the pre-event, because the conference is starting tomorrow. So if you didn't book a place yet, please do it, because we have a lot of excellent talks by experts, as the experts we had today here, speaking about quantum mechanics and technology, especially. Thank you very much to all of you. I hope to see you very soon again.
Bye-bye.